So when using spray can like this one, they did require you to shake for about a couple minutes. So like, oh yeah, this one's just 2 minutes. I remember some of them require you to shake for a lot longer, I suppose. 1 second. To manipular something about 2 to 3 minutes. So it's not really that long. But 2 minutes of doing all that kind of wrecks my wrist a little bit. And when you have to do multiple coats 10 minutes apart, it can get pretty annoying, and I don't think that is good for my wrist, doing that kind of violent motion. So that is why I look online for some of these designs. So like a spray can shaker, Adam Savage made a video about that. Most of them involve a drill like that, or some more autonomous mechanism. But overall, yeah, they involve spinning some things up. They do sell an off-the-shelf version, so I have sketched out 2 versions. One of them will require a power drill to work, and I will have to like hold the button for it to spin. The other one will be connected to my Dremel with the herringbone gear, with the smaller gear and the bigger gear. This will reduce the number of rotation and increase the torque, which will allow me to spin the spray can. And the Dremel have a nice feature is that it uses a switch instead of a push button. So I can just set it in, flip switch, and let it does its thing without having to hold anything in my hand versus this version. However, the journey of 1,000 miles begins with a single step. Doing it with a Dremel can be a bit annoying because I have to measure the jig. I have to create a jig to hold that Dremel, create a way to hold the transmission system in place. I don't know how to interface the bearing together. I'm still working on that. But this one is a lot easier, so it's kind of explain why it is so popular. But yeah, so I think we are going to make this version first. Now, if we are just going to spin it directly like this one, so yep, so that's why we're making this one first, getting it easy, test out the concept. Now if we're just going to spin it circularly, the centrifugal force will just force everything outward and nothing will really get mixed. I think it has something like a medium and the actual paint, so you have to like rotate the drill around to get it to work. That is why some of them have a kind of an offset, so they kind of do this kind of motion. So like, yeah, so they spin around a center axis like that one. So that's kind of my plan for now. Create a kind of offset and try my best to envelop the entire structure. Yeah, because the problem is that spray paint can came in a variety of sizes. Adam Savage encountered this exact problem. So yeah, I will try my best to avoid that one. So I prepared myself a really big bolt and nut and washer. Like washer, nut, and the 3D printed part is the one that will hold the spray can. It will slide in like that, and hopefully the torque will be transferred sufficiently via these edges and not rip the plastic apart, hopefully. Yep, so that is the plan. So like the chuck will hold this end and spin it really fast. So like let's get started to sketching. Okay, let's start with, I would like to start with the cylinder, maybe. Yeah, I think starting with a cylinder is the best approach. So 1GC, let's create a cylinder. Now, about a spray can, I think we should have some kind of mechanism to allow a variety of spray can to be held. However, I'm going to just first measure a couple of dimensions. So, really sharp. This one is 61, no, 66. Let's note it down. One of them is 66. The other one from the same brand should also be 66. Yeah, kind of makes sense. The one from the Red Fox brand, the diameter, also 66. All right, let's double check the last one. Spray flat white primer. Okay, so they are all about 66 millimeter in diameter. Let's note it down first. So let's sketch the inside and no, let's sketch the outside diameter first. So we have the inside that is 66 millimeter, right? But we need the outside diameter to be a lot bigger than that. Let's give it something like 80. 8 0. Okay, 80 millimeter. Extrude upward by how tall should I make it? I think making it 100 should be good, right? Or should I save the space and make it smaller? Nah, I think 100, maybe 70. 70 is a much more reasonable height. Let's go for 70. Alright, we got a cylinder. Now I will... Okay, how am I going to create the hole for that one? Okay, let's measure the bolt. So right now we are going to get the shape of the bolt inside first. Yeah, because the bolt have to slide down. So creating a sketch in the same plane. Yep. And let's turn that one off. Use the hexagonal shape tool, just like so. Don't know about the dimension yet, so I'm gonna leave it at that. Make sure that one is horizontal. It's a 0, the caliper. Just a tiny bit of oil and dirt is enough to throw the measurement out. This one is 10, looks like 13 millimeter on this side, that side, that side. I hope the thermal expansion can help with that. I hope the thermal contraction doesn't throw up the measurement by that much. It's like 0.20 millimeter. I hope the measurement doesn't. So like 13 millimeter from here to here. 13. Okay, that one. And we will enable that one. I will shift extrude upward through all just like so. So we have okay, maybe not by that much because I yeah, maybe not by that much because I need to offset this thing by the thickness of this. Let's measure a couple more things. The thickness of the head is that much, huh? Let's give it a lot of wiggle room. Let's give it 30 millimeter of space inside the holder. Okay, seems like a good number. So select the sketch attachment and select the offset by Z by 30 millimeter, and it should, yep, should looks like that. Let me turn this one up. VT, yeah, so it's now transparent, and you can see shift it up. If we measure from here, yep, you can see it is 30 millimeter apart, and that is because we need to make a hole for it as well. So let's do that. Let's name this one first, right? Bolt head pocket. Perfect. Let's create another sketch on the same plane. GC is a circle. This will be the thread of, I'm sorry, the diameter of the bolt, and it is 0.6. Let's give it 8 millimeter. I hope that will fit. Yep, 8 millimeter should fit. Let's shift extrude upward and through wall. Nice. Now we got the hole for the bolt thread. Let's give it a name so we can review it later. Bolt shaft. Yeah, I think it's called shaft. AFT bolt shaft channel. Yeah, that's the name channel. Let's call this thing counter bore. Make a lot more sense. Counter bore. Okay, we got a counter bore, we got a shaft. On this end, we will just use a washer. I have a really big washer on this end and a big nut on this end as well. And the plan is to secure them on this end so this end can be flat. It is also the side that will be contacting the bed, so yeah, I don't think we need to modify it anymore. We don't need it. Got that one, okay. If we, let's name it cylinder. Is it a cylinder or piston? Let's just call it cylinder. 70, maybe 100 should be a better number, right? Because we need, yeah, quite an amount for the actual spray can. Now we got that one. How are we going to, okay, let's create on this plane. All right. Okay, diameter 66, right? Let's give it G rectangle. Here to here is 66. Here to here something like 50. No, 60. It's not, shouldn't be vertical, right? They should be parallel to each other. Yeah, I think that we have the problem right now because it needs to be the cylinder actually needs to be a lot bigger than that. Remember when we said that the bolt head is 5 millimeter? Yeah, okay. Oh, I need to note it down as well. Okay. So yeah, we are back. Maybe 20 degrees, a bit much for an offset. The bolt head is that much, huh? So, how should I? Yeah, how should I formulate this one? Ooh, really tricky, pretty tricky right now. Mm, yeah, how should I formulate this one? Because I can definitely set off that sketch, right? Turn off everything so I can reference the edge of that sketch. So now we got the thing there. Move it up by 5 millimeter, right? So up there to there is only 5. Let's create a rectangle. G rectangle. Give it a here to here, here to here, and this one is 5 millimeter. So that is the clearance. That will be the clearance that we are allowed to work with. This is the lowest point. So let's make it coincide. Yeah, so it will always fall on that line. Should I make this line center as well? maximize the space by allowing it to offset like that. If we do that, we can definitely go for more extreme angle. Yeah, like so. So what is the methodology we should do here? Hmm. Oof, it's getting really tricky. How about I set another constraint for the edge over here? So we go back to the cylinder sketch, turn that off, GX, and reference the cylinder, reference that circle. Okay, now we got the upward limitation. Let me just sketch it out. Yeah, coincide. Right now it is just, let's give it a number. Should be good enough because we just want it straight up. The distance from here to here, I want it to be consistent, so we don't have a very thin wall. Okay. How are we going to set that up? Okay. I think this should go for the var set. Let's go for offset angle. Property, not length, angle. Give it by 20 degree. This one should be length. Min wall thickness. Let's give it a number by 3. Yeah, 3 is a good number. And close. Let's get back to that. GY instead of a line, instead of a point, make it coincide. GY, set up a point. Make sure those are horizontal. And then we will set a dimensional constraint for it. Var set min wall thickness. Same for that one as well. Okay, yeah, that doesn't work, right? How about I turn the angle off? Okay, yeah, I think I see the problem now. What I really should be doing is to make a construction. I shouldn't make them horizontal like that. Huh? Let's just make a line here to here. Same for this one. Seems a bit redundant, to be honest, but okay, how am I going to set that one up? Yeah, that's the problem. Okay, gonna horizontal like that. No problem here. Okay. Coincide, please. Horizontal, please. coincide, please. Okay, now you two have to be equal to each other. Nice, nice, very good. Create a raw set with offset angle in mind. Okay, we got that one. How tall is the spray can? Let's just Google it. How tall is a spray can? 158. Yeah, let's give it a number like 158. 158. And revolve, groove, not revolve. Groove. How about, oh, okay, construction line. What is the construction line one? Ooh, I can't. Angle to all. Oh my goodness. Okay. I want to revolve that one around itself, around the construction line that I created. How do I do that? Looks like the correct one. We'll intersect the sketch 2 times. Every single one, and pray that one of them will work. Because I don't understand how to select a construction line. Mm-hmm. Wait, wait a minute. Okay, I think we had it right. Is there even a name for this construction line that I made? Ooh. Uh, I want to revolve it around that axis. Mm. Okay, I think we need some help right now. Let's see what the internet have for us. FreeCAD how to revolve groove. Nope. Nope. Maybe this
In
one.
this video of FreeCAD series, we're going to talk about Groove tool. So let's see how actually easy it is to create a groove in your geometry. And for that purpose, I'm gonna use this sketch, and I'm gonna plot a line here. I just came out of it, and we need to click on wireframe, fill here, construction edge, and can form. Let's trim the extra. You can, for a groove is being created. All you need to do is you need to select the groove tool, and there you go. We have created groove across this geometry. As we have selected the run case, the to form also go symmetric to the plane and reverse as well. And the first one is through all. Then we have got to first up to face and to dimension plane display so that we all understand what's going on. The dimension use in the way here is kind of buggy because still different. Let's make it shade. If I say one group to I actually in another option, and I hope that FreeCAD will fix it soon. So in this way, guys, we can create.
Not very helpful. Groove along path. What the heck is that? Am I using the wrong tool for this job? Definitely not pocket, right? Groove seems to be, you know, around a line or axis. So how about I make this line a normal line, like it's just a construction line, and select the groove. Okay. Select reference. That reference did it work. Why not close? Of fucking course it is not close. So like, do I have to place a construction line manually? Yep, I think that one. Yeah. Okay, yeah, datum. I need a datum access because I cannot use the construction line. Okay, how do I create that one? Maybe D. I used to set that up as a datum plane. We have that. Oh, oh my goodness. This is taking way longer than I expected this to be. It is a very simple design. Yet it is taking me quite a while to figuring how to sketch that one. What the heck? This one is actually the mentality of the channel, right? We don't know how to work. That's why we're learning it step by step. So groove. How about I just give it 180? Printed this one with the offset. Sorry for the late delivery, but I put it in a drill, and the offset angle turns out to be a little bit too much. Not enough to fling the can out, but enough to shake the whole thing very violently and make my hand very sore holding the drill. So kind of defeat the purpose of using machinery to help me work with it. So right now we're going to try a simpler version with a bit of a chamfer to save on material as well. So this is our design straight on. We'll try to like rotate the can a little bit and also tighten the diameter of this one. Hope this will work. Okay, so we are back a little bit. Get that wide angle. So this is the first version printed with transparent PETG. You can actually see the angle of this thing. Oh, yeah, it shifted this way. The problem is that it shakes a little bit too much, and the diameter is completely wrong. And yeah, it shakes too much to be used with a hand tool, hand drill like that. So that is why I try to make a simpler version with no offset angle, thinner wall, so it can be printed faster with less material waste. And I use some tape to secure the spray can. So now it kind of slide in, but it doesn't slide out easily. There's just that tiny bit of tape, nano tape, to help it glue together. The surprising part is that the print with thick layer line and 2mm extrusion width came out surprisingly clear. I think with a couple, this is a double wall, a double or triple wall, so it looks a little bit cloudy, but yeah, I believe with a single wall the result will be much more preferable. So I just connected it with a nut that I have, and it still have that tiny little bit of shake because the can is not completely centered, but yeah, it is much easier to use. So I try not to spin it too fast, and the point is to still get the rattling of the glass marble inside, because spinning it too fast will probably make it, you know, stick to the side of the cans. Yep, and I believe that it should be enough to make mix all the paint and the lacquer inside. So yep, that is my progress on the automatic spray can, like semi-automatic to be honest. Yep, it will definitely help save my wrist a lot more. I didn't have to shake this thing 2 or 3 minutes by hand, maybe just 30 seconds on this thing, pop it down, use that nano tape to hold it, and give it a good little spin, because most of the time I have to do at least what I do is I do at least 2 coats to get good coverage on this thing. So yeah, I have to shake it for 2 minutes, spray it, wait for 10 minutes. I have to wait for 10 minutes in order for the surface to dry so I can spray the second layer on this thing. And during that 10 minutes, a little bit of paint might get settled down or something like that, and I find that shaking it will help a lot. I had a problem with one of the spray can before because I didn't shake it. I didn't really shake it much at all. I can still feel there's some liquid paint down on the spray can, but all the compressed gas has been let out. So when I press, there's nothing coming out because all the propellant has escaped, but the material, the paint, is still left there because it didn't get mixed properly. Yep, and as always, the journey of 1,000 miles begin with a single step.